Alright, hopefully you can hear me pretty well. Let me just... 1 second, hold on. Give me 1 second, guys. I'll be right back. Okay, hold on, guys. Alright, hopefully it's streaming. I'm hoping. Okay. So, okay, so in this live stream, guys, and, let me open up, OneNote here. Hold on. So in this live stream, I'm going to go over the integral of secant. Now, of course, I'm going to go over the detailed explanation. The truth is, guys, that for me at least, and I don't know if any of you guys are on the same page, but when it comes to the integral of secant x dx, I could not understand why they multiplied by, I think it was like secant x plus tan x or something. I don't remember exactly, but we're going to go ahead and just do it another way because I feel as though the way that it is done on YouTube, or how most people do it, or even how textbooks show you how to do it, is way too complicated. So I'm going to show you guys how to do it in this live stream. And the reason why I'm doing a live stream and not a video is because this problem is really difficult. I'll do x. And then dx like this. So here, we're going to go ahead and just, hold on, guys. Try to, give me 1 second, everybody. Hold on. Try to go over here. And, okay. Give me 1 second, everybody. I am just going to go over here and let me just go over here and try to hold on, guys. Okay, guys, so sorry about that. We're gonna get started right away because I don't want to waste too much time trying to pause here. Now, this one, like I said, is very difficult. It is very difficult. A lot of people don't find it as difficult. There is a shortcut way to do it, But the thing is that if you don't understand why they're doing it like that, I am just going to do it this way. Unfortunately, this method is longer, but I would rather explain exactly how to do this method than do a method that just, at least to me, I'm sure for others it makes sense, but to me it did not make sense. So I'm going to do this following method. Okay, so here we are going to go ahead and first we're gonna, so remember that the integral, and let me make sure my pen is on, the integral of c, so we have the integral of secant x dx, and one of the things is that, one thing is that we must remember that from trigonometric identities, secant of x is 1 over cosine of x. So I'm going to rewrite it that way. So in other words, this is going to turn into the integral of 1 over cosine of x dx. Now, this is where it kind of gets difficult. The thing is that we have to, apparently, we have to multiply the top and the bottom by the, how do I say it? By cosine on top and bottom, by cosine x. At least that's how I did it. And if you're wondering why, it is so that we can get the bottom of the form of a Pythagorean identity and use U substitution. Again, guys, I mean, honestly, I don't know why they're doing it this way, but this is one of the ways that I know how to do it. It can be done, I think, for other ones as well, but I can't quite remember for other trigonometric functions or integrals, but I just don't remember off the top of my head. So what we're going to do is we're going to multiply top and bottom by cosine x. So we have the integral of 1 over cosine of x dx equals, and it's going to be, if we multiply again, we're going to multiply times cosine of x over cosine of x. And of course, I mean, really, it's actually going to be like this. Okay. I'm trying to think here. Hold on. 1 second, guys. Give me a second, really quick. Hold on. Hold on. One second, guys. I'm just trying to see what I did here. Okay, so yeah, I mean, I cannot quite explain why we do it this way, but we are going to do it this way. At the end, we are trying to make it so that one of the expressions can be used, but can be integrated by U substitution, or by partial fractions and then U substitution, so on and so forth. So we're going to go ahead and say that this integral is equal to the integral of cosine of x over cosine squared of x dx. Now, here, we must remember the Pythagorean identity for cosine squared x. Remember that cosine squared of x plus sine squared of x is equal to 1. So, if we solve for cosine squared, we will get, we will go ahead and get, so let's solve for cosine squared. We're going to subtract sine squared here. And so here, we're going to do, cosine squared of x is equal to 1 minus sine squared of x. Oh, and actually, guys, you know what? Well, I'll just keep going. I just realized something. I'm really stupid. This can be also done by integration by parts. I really did not realize that. Oh my goodness gracious. I'll just do it this way since, I guess, but, I'm gonna do it this way, and then maybe I'll do it by integration by parts so that you guys can see both ways. I'll have to see, I don't know, but, I should have just done it that way. I don't want to start over again, so I'm just gonna keep it the way it is. So, hi Light, welcome to the stream. Thank you for watching. I really appreciate it. Make sure you like and subscribe if you haven't. Like the stream. Oh no, with this one, like, honestly, that's why I'm live streaming it. This one was really hard. I hated it. I hated this one. I really struggled with it. It was very difficult. I could not understand why they did, like, I don't know what they did. They did, like, times, secant plus tangent or something. It was weird. I don't know. I didn't like that method, so I'm doing it this way. Okay. Here, we're gonna go ahead and put, so this, expression here is gonna go in for this. So now, this integral becomes the integral of the cosine of x. If it lags, guys, or it looks choppy, like the writing, I apologize. I don't know why it keeps doing that. I don't know how to fix that. It's been doing that for the longest time. And I'm not using my Surface Pen. I'm using the other one because my Surface Pen is, like, out of battery or something. That's why it was, like, acting up. Alright. So like I was saying, if anybody has questions, let me know. I'm looking at the chat right now to see if anybody has questions, because I don't want to, and I'm also trying not to go way too fast with this, because I understand how frustrating it is when teachers or anybody goes too fast with a problem, and it's like, oh my god. I know organic chemistry tutor does that, and it's crazy. Because not everybody can understand that quickly or go at that pace. So I always go slow for those that really need it. Now, we're going to write this as 1 minus sine squared of x. So it's going to look like this, right? Now, I'm trying to think here. Oh, goodness gracious. So, this is where it kind of gets really interesting here. I'm trying to think. So, if I do, hold on, guys. I just want to make sure I understand how to, can you read it, Light? Oh. Yeah, thank you. I think I was gonna do that. Set sine of x equal to u. Let me think. Hold on. Yeah, so here u will be sine x and du will be cosine x dx. Good. Yes, so that's what I'm gonna do. It is difficult to know what u would be and what du would be, at least for me. But honestly, just remember that du has to cancel out with the top, at least I think. So in other words, we need to make u equal to sine x. And then du is going to be cosine x. That's what I did here. I just hope that makes sense because, I mean, you just have to test it out. Like, we're not going to let u be sine squared or 1 minus sine squared because that wouldn't make sense. We have to make sure it cancels out with the cosine x. Like, we have to make everything in terms of u. Okay. So u is going to be sine x. Du will be cosine x dx. I hope that color is readable. I will. Give me a second. I'll explain in a minute. Because this is gonna actually be integrated by partial fractions. I forgot to put that in the description. We're gonna use oh yeah, I did put it in there. Basically, I'm gonna do it by partial fractions. So du is gonna be cosine x dx. I don't know why it writes this way. Stupid thing. Oh my god. Shit. Okay. If you can, Light, please do put hearts as well so that I can get more people maybe. I don't know, because I do that, but I don't know if that's even available. If you put like on top messages or live messages or something, it'll show a heart symbol that you can tap. I don't even know if that's possible though. I don't know if you have to like the video first. I don't know. But if it's not, it's fine. If the heart thing is not there, it's fine. Don't worry about it. I was just wondering because yeah, I mean I feel like it brings more people, but I don't know. Anyways, we're gonna do, so now it's gonna be the integral of, and so the cosine of x dx is gonna be it's gonna be my du. So I'm just gonna rewrite it here. This is gonna go in for this. Oh, I see, okay. And then this is going to go in for that, but it's going to be squared. So we're going to have, so therefore we have, thus, we have the integral of 1 over, I'm sorry, excuse me, of du. It's going to be du. Let me move this over here. Du over 1 minus u squared. And you're right, Light. It's going to be 1 it's going to be the sum and difference pattern. I will show you guys that formula just in case nobody knows it, just for those that don't know it, because again, I know that not everybody knows their algebra, so I know that I don't have to do this, but I want to make sure that we understand where we are getting everything from, okay? But thank you, Light, for putting that in there. I will just reiterate it. So, it's going to be, yes, it's going to go 1 over 1 minus u squared. Now, here, we're gonna go ahead and just do, so we have to integrate the following. Du over 1 minus u squared. We need to factor 1 minus u squared. If you guys remember from the sum and difference pattern, I'm just going to write this really quick. Again, I know I don't need to do this, but just in case, whoever needs it, here you go. Parentheses u. I'm gonna say a minus b parentheses a plus b is equal to a squared minus b squared. Okay, and you can verify that when you FOIL it. But yes, we must understand this rule because we need to use this to factor the bottom. This is why it's so important to know your algebra. Give me a second, guys. I'm going to get some water. Okay. So therefore, when I factor 1 minus u squared, let's do it this way. 1 minus u squared is really 1 squared minus u squared, which is equal to the quantity 1 plus u times 1 minus u. So yeah, I mean, basic algebra there, just algebra. Not really calculus, it's just algebra, but we need to do that for our calculus problem. Hold on, guys, I'm sorry. Okay. So again, we're just going to do 1 plus u, 1 minus u. And so, the way this is going to go is the following way. We're going to have, so therefore we have the integral of du over the quantity 1 plus u times 1 minus u. We need to do partial fraction decomposition. We have to. Okay. In other words, I mean, yes, you can write it this way. You can also write it the following way as well. This is going to be another way to write it. This integrand, which is what we're integrating, is going to be the integral of 1 over 1 plus u times 1 minus u du. Okay. Excuse me. So we need to do partial fraction decomposition. So really, so integrate by partial fraction decomposition. Okay, guys. So here we're going to have that the integral of 1 over 1 plus u times 1 minus u du. If we actually do this, 1 over 1 plus u times 1 minus u, oops, is it going to be equal to, and the way that I usually do this, guys, I know a lot of people use systems of equations. I don't do that because honestly, it is confusing to me to do it that way. So I'm going to do it the way that I usually know how to do it. If y'all want to do it by systems of equations where you find A and B parts, you can do that. But I'm going to do it the way that I know best, because the other way, to be honest, to me at least, it's very difficult. I take way too long to do it the other way. Okay. I mean, I can do it by systems of equations. Let me just see for a second. Hold on. Maybe. A times, so we're going to really cross multiply here. A times 1 minus u plus b times 1 plus u is equal to 1. And then here we're going to go ahead. Let me think here. Actually, I'm not going to do it by systems of equations. Never mind. Screw that. I don't want to do it that way. It's too tedious. But you can do it that way if you want. Expand and recombine terms. Like, you mean distributive property? Yeah, that's why I'm doing it this way. I don't want to do it the other way. It's too hard. I can, but let me see. I'll try it. Oh god. This is what I mean. Oh, plus BU, my bad. Yeah, plus BU, sorry. From here, I always... Oh my god, this is where I mess up. BU minus AU plus A plus B equals 1, I think. U times B minus A plus A plus B equals 1. No? Is that like that? Am I doing this right? a plus b equals 1. What? I'm confused. Yeah, this is why I don't do it this way. This is exactly why I don't do it this way. It's very difficult. Wait, But that's what I did before, though. I think the one way I know how to do it I just don't know how to do it this way. It's too difficult. Because yeah, this is why I hate partial fraction decomposition. It's really hard. It is really hard. I know how to do it with these, but I know how to do it whenever you're just doing it by the whatever, whenever you make like u equal to 1, u equal to -1, so on and so forth. But I don't know. Lord have mercy. Trust me, just go from a plus b equals 1, a equals b minus 1. I mean, I know that's systems of equations, but I am trying to figure out... Are you making it equal to 0 somehow? Because that doesn't make sense. Oh my god, they're so loud. Then so then, hold on. Just go from a plus b equals 1. The thing is... Are you saying to subtract a times 1 minus u plus b times 1 minus u? No. I don't think so. Hold on. Give me a second. But the x term, this is the problem. The x term, so like, okay. U times b minus a plus b. What if I say... This is why I don't do it this way. This is exactly why I don't do it this way. It's too difficult. I don't think I'm doing this right. I'm not, am I? I am not doing this right, am I? Hold on. No. No. Is this correct? Shit. Oh my god, I don't know. This is really hard. I hate doing it by partial fractions. Oh my god. Like, I hate doing it by systems of equations is what I'm talking about. Oh my god. That makes no sense, though. Is that correct? I just don't know. This is not the way that I do it. Cause like, okay, the thing is, I forgot how to do this. So, let me think here. Hold on. Give me a second. Give me 1 second. You're telling me 0u squared and then plus bu minus au, which is the kind of the second term, right? And then plus oh, I remember this. I do remember this. Thank you. Thank you. I'd remember this now. It's 0, yes, 0u squared plus 0u plus 1, yes. Thank you. I remember now. Sorry. It's been a while for me. So now I know that this is equal to this. This equals this, I think, and then this equals this. And so then so of course, because they both have a u, yes, they both have a u here, b minus a is 0. And then a plus b is 1, I think. Or I'll say b plus a in this case. But the thing is, that's interesting. Because the way that I saw it was a little different. Then again, okay. So now I'll get b is equal to a. So b minus a is 0. Actually, you know what? This cancels out. 2b is equal to 1. b is 1/2. Right? Is that? Yes, perfect. That's what I got earlier. I just didn't do it this way because I don't like partial fractions. Or I don't like doing it by systems of equations. It looks hard. I always confuse that. And so a plus b is 1, right? So then a plus 1/2 is 1. If I multiply by 2 on both sides, I get 2a plus 1 equals 2. Minus 1 on both sides. 2a is equal to 1. Divide by 2, a is equal to 1/2. Yeah, I don't do systems of equations. It's too difficult. I hate doing that with partial fractions because it's about how you arrange it. Once you get to the systems of equations, it's not hard. I just have trouble arranging it for some reason. It's very difficult. Okay, so then what we're going to do now is, now we have a and b. So, in other words, our integral becomes, so we have the integral of 1 over 1 plus u times 1 minus u. Du is equal to a over, Jesus Christ, hold on, over 1 plus u plus b over 1 minus u. So and it's equal to, and we just said it, a is 1/2, b is 1/2. So we're just going to put that in. In other words, really what this means, guys, we're just going to say 1 over 2 times 1 plus u. I hope that makes sense, unless y'all want me to explain that. You're just like putting the 2 in the denominator. I mean, it's like, it's when you like do a fraction divided by a whole number. I mean, you're just putting the denominator of the top fraction on the very bottom. So yeah, 1/2 over 1 plus u is 1/2. Yeah, so just that. I'm not really going to explain it unless anybody wants me to, but okay. So plus 1/2 times 1 minus u. And so we know that this is our entire integral with respect to u. I think, right? Yeah. Yeah. Now, we're going to split it up into two different integrals. This is, remember that the integral of f of x plus or minus the integral, plus or minus g of x dx. If y'all hear background noise, I am so sorry. My brother and sister are so loud. Is equal to the integral of f of x plus or minus the integral of g of x. Oh, the integral of f of x dx. So it's just the addition property, guys. Kind of like when you're, when you're doing like the derivative of two functions added, it's the derivative of the first function plus the derivative of the second function added together. Goes the same for integration. I'm just writing this rule down really quick. I know I don't need to, but yeah. So in other words, this entire thing is going to be the integral of 1/2 times 1 minus u du plus, hold on. The integral of 1/2 times 1 plus u. I don't know why it keeps writing this way. Golly. Plus the integral of 1/2 parentheses 1 minus u du. And so this is going to end up being, it's really 1/2 integral of 1/1 plus u plus 1/2 integral of 1/1 minus u du here. There's a reason why I'm doing it this way, guys, and it is because the second part of the or in other words the the one where I have to do the integral of 1 minus u, I have to be careful with that. So give me a second. This is going to end up being the following. So if I do the integral of 1/1 plus u du, I can let v equal u plus 1, and dv is going to be, dv is going to be du. So in other words, I'm going to have the integral of 1/v dv, which is the natural log of the absolute value of v. And so if we put u back, or if we put v back in terms of u, this is going to equal to, plus c, which is going to be equal to the natural log of the absolute value of 1 plus u plus c. That is this part. Now let's do the one with the 1 minus u. So it's going to be the integral of 1/1 minus u du is going to equal to, again, I'm going to make v equal to 1 minus u. So v and then dv. In this case, dv be negative du. Now, we're almost done with this, guys. I know it's a lot. It is really difficult. It's a lot. This is gonna be, hold on, what would it be? The integral of 1 over v. And if I divide both sides by -1 here, because I'm going to try to solve for du here, I want to make sure this is on its own right here. So in other words, du will be negative dv. So du equals the negative of a negative dv. So in other words, we're going to have times negative dv. Oh, God. So then this will give me the integral of negative dv over v, which is equal to the integral of -1 over v dv, which is equal to negative the natural log of the absolute value of v. And remember that we had made v equal to u plus, or 1 minus u, excuse me. So in other words, we're just going to back substitute that. So, in other words, this is going to equal negative natural log of the absolute value of 1 minus u, I think, was what it was. Yes, 1 minus u plus our constant of integration c. And so this is what we're going to put in for, this is what's going to go in. For this. Excuse me. So, therefore, I'm just gonna let me copy and paste this. If y'all hear background noise, I'm sorry. They're being so loud. Okay. Now, we're almost done. We're gonna put this into that, we're gonna put that in for pink, and then for the blue part, we're gonna put the natural log of 1 plus u. So, for the blue part, this part, this was this, okay? I wouldn't put a plus c yet, just this, just put it like this, because at the very end we're going to put a plus c. I don't want people to think I'm adding it twice, or the constant of integration twice. I'm like really OCD with like how I show my math, guys. It's crazy. I don't know. And then of course, like I said, this is what we're going to put in for this. So therefore, thus, we get 1/2 natural log of 1 plus u plus, I'm sorry, it's gonna be minus 1/2 natural log of 1 plus u, or natural log of 1 minus u, because it's plus negative, so it's going to be minus 1/2 natural log of 1 minus u. Of absolute value of 1 minus u. I keep forgetting to say that. Plus our constant of integration c. Now, this is where we are almost done, guys, but now we have to just form it back into the way that we want it, because our answer in reality, guys, has to be the natural log of secant x plus tangent of x. Natural log of absolute value of secant x plus tangent of x plus c. So this is our answer, but we're going to have to form it this way. We're going to have to, like, I'm going to show y'all how to get it to that point. And this is where it's just a lot of trigonometry and algebra at this point, you know, laws of exponents, trig identities, so on and so forth. So bear with me. We are almost done. We're almost to the finish line. This is really difficult. That's why the way that they teach you this, and whenever they say to multiply by the, I forgot by what, by secant plus tangent or something, or by, I forgot what, it just doesn't make sense. But anyways, let me think. This is going to be 1/2 times the quantity, the natural log of the absolute value of 1 plus u, minus the natural log of the absolute value of 1 minus u. All of this plus the constant of integration c. But remember that by the properties of logarithms, the quotient property says that the natural log of a over b is equal to the natural log of a minus the natural log of b. Okay? So then, in other words, this is going to be 1/2 times the quantity, the natural log of the absolute value of 1 plus u over 1 minus u. All of this in absolute value. I'm thinking. And I might have just, I might have outdone myself with the very last part. I am gonna, hopefully this does not make it way too difficult, but this is where it's just a lot of work, guys. We're almost done. It's just algebra and trig and whatever the hell. But it, you know, just bear with me. What we're gonna do, we're going to put, hold on. We're actually going to, we're gonna make it so that the 1/2, we're gonna use the power property. And that is that a natural log of u, I'm gonna just use u over v is equal to the natural log of u over v of the following, u over v to the a. But in this case, we are going to use square roots because how do I say it? The power is 1/2. So we're going to turn that into radical form. So it looks like this, apparently. Oh, I'm sorry. It's supposed to be blue. So if I let u equal to 1 plus... I know this is really... I shouldn't have used u, but whatever. I'm going to say this. So I'm just going to say the following. This is going to be... So 1/2 ln of 1 plus u over 1 minus u, thus 1/2 ln of absolute value of 1 plus u over 1 minus u is equal to the natural log, or ln, of the absolute value of the quantity 1 plus u over 1 minus u. And for now, I'm going to take off the absolute value. I'm going to say it as a parentheses, and I'm going to put the 1/2 up here. Now, you remember, guys, that if I have u over v to the 1/2, this is u to the 1/2 over v to the 1/2. So this is going to be equal to the natural log of the quantity 1 plus u to the 1/2 over 1 minus u to the 1/2. We are almost done. I know, guys. I know. And so, from here, we're going to say, we're going to turn this into radical form. In other words, we are going to say the following. This is the natural log. Remember that u to the 1/2 over v to the 1/2 is really the square root of u over the square root of v, which is really the square root of u over v. That is an algebraic property, guys. You really have to know your algebra really well, otherwise it's going to be so difficult. We're almost done. This is going to be the natural log of the square root of 1 plus u over the square root of 1 minus u, which is equal to the natural log of, actually, I'm sorry. Actually, just keep it like this, guys. Keep it like this. Don't even put the whole square root like that. Unless you did do that, then just turn it to the square root of the top over square root of bottom. From here, we're finally gonna add our constant of integration, c. But this is where it gets interesting. U was, what did I say u was? Oh god. At the very beginning, I had said that u was Jesus Christ. Sine of x. U was sine of x. So, oh, and also, guys, this is the thing about this one I forgot to mention. Apparently, you have to multiply this part by the conjugate, okay? In other words, or you're gonna have to rationalize it. In other words, I don't even know if I can do this by logarithms, though. Because what I'm gonna say is that the square root of 1 plus u over the square root of 1 minus u, I'm gonna multiply the top and the bottom by by square root of 1 minus u. Okay. And so this is going to give me the square root of 1 minus u squared over 1 minus u. Yeah, this method is really long. I am so sorry. You can watch it after I'm done live streaming it. It's ln of secant x plus tan x. I'm almost there. I am almost there. Let me think. Oh God, okay. Oh my goodness. So, okay. U was sine theta, right? So, just remember, U was sine theta. Or x, U was sine of x, whatever, right? Because I used theta when I did it on another paper, but I used x when we're using x here, not theta. But anyways, this is really gonna end up being the natural log of the absolute value of the square root. I'm sorry, it's gonna be yeah, it's gonna be the square root of 1 minus sine of theta quantity. I'm sorry, sine of x quantity squared. So it's gonna be 1 minus, and like I said, this will go in for that. Because I rationalized this, so whatever was in here became this, okay? So we're just gonna go ahead and we're gonna put it all together. 1 minus the square root of 1 minus sine squared x over 1 minus sine x. I'm trying to think here. Oh my God. Which is really equal to, it's really going to be the natural log of the absolute value of the square root of cosine squared x, because sine squared x is 1, I'm sorry, 1 minus sine squared x is cosine squared x. So we're just doing that. And then here, we're going to put it over, oh my goodness, we're going to put it over 1 minus sine x. Oh, this is exhausting. And so then, this is gonna be, give me a second. It's gonna be, can I integrate 1 over 1 plus cosine x in 2 ways? Maybe. I'll have to see. I'm gonna try to do that. If I can do this, I'll do it after this one. I don't think it's that complicated, to be honest. I don't even think you need 2 ways. I'm not sure. I mean, I don't think you need 2 ways. I know one of the ways. I don't know if I know both, though. I'll have to see. So this is ln of the absolute value of cosine x over one minus sine x. If you guys think about it, you can just, let me think here. Oh my god, okay. How did I do, okay. Now, the thing is, guys, you're gonna have to, you're gonna have to do conjugate again, or rationalize again, okay? This expression here is gonna end up being, so we're gonna do cosine x over 1 minus sine x. We're gonna multiply by the conjugate of that. To get it so that on the bottom it has a 1 plus, or a cosine squared x on the bottom. So in other words, this is going to be cosine x times 1 plus sine x over 1, I think it's, so it's 1 minus sine squared x. But then again, this part is equal to cosine x over cosine squared x, and then on the top it's times 1 plus sine x. And then finally, we know that from laws of exponents, this is equal to cosine x over cosine x times cosine x, and then we had times the quantity 1 plus sine x. And then from here, we and then from here, we're gonna just cancel this one out. We are gonna end up with 1 plus sine x over cosine x. And so again, we simplified the inside of the, this is what we were simplifying here. So that is what we're going to put in for that. So now where this becomes the natural log. So in other words, the 1/2, I forgot to put it on the, hold on. Oh, Jesus. What the hell happened? Oh my god. Okay. Hold on, guys. Oh my gosh. Lord have mercy. Golly. Well, okay. This is what we're gonna get for the whatever the algebraic expression or the trigonometric expression inside the natural log will be. So we're gonna put that in. So it's gonna be I just don't know if wait. Oh, okay, yeah, it did not have, did it have a 1/2 on the very end? Godly, I don't think so, right? It doesn't have a 1/2 at the end, does it? Like when it's 1/2 ln of absolute value secant theta plus tan theta? No, right? I don't think so. I don't think so. Oh my goodness. This is just crazy. Oh, okay, yeah, no. It's just gonna be natural log of secant x plus tan x. So it's gonna be this. Thus, the integral of this secant x dx is equal to the natural log of 1 plus sine x. Or I'm sorry, it's gonna be, this is gonna equal this, hold on, it's gonna be 1 over cosine x plus sine x over cosine x, which is really secant of x plus tangent of x. And so then our answer then becomes because, okay, yeah, so let me see. Oh my goodness, did I mess up somewhere? Okay, so this is what I'm saying. The square root, when I did to the 1/2 power, I mean, really, it was right here, right? I just don't know why I put this stuff over here. Oh my gosh. Let me rewrite this part. This was ln of 1 minus u, or 1 plus u, and it was to the 1/2 power. That was what led me to say, well, this is natural log of the square root of 1 plus u over the square root of 1 minus u. And that is where I went ahead and, you know, did all that stuff with conjugates and stuff like that. Why is it crashing on me right now? Oh my god. Okay. Well. And so, therefore, our answer becomes the integral of secant x is equal to the natural log of the absolute value of secant x plus tangent of x plus our constant of integration c. Yeah, you can. You can. Yeah, you can do that. You can do that. I guess I went a little overboard there. But you can do that. That's fine. I mean, honestly, sometimes I feel like I make it a little too difficult, and I probably shouldn't have done it as difficult as I did it. But yeah, you can do that too. I mean, whatever, if there's a more shorter way for you to do it, then that's even better, because I do feel like sometimes I overcomplicate it. Now, when you were talking about the integral of 1 over 1 plus, what was it? Cosine of x. This is the last one I'm gonna do, by the way, but let's see here. I know that, like you said, prods, I think is how you say it. You can do conjugates. The other way, though, I have no idea. That is an interesting question. Let me, look at my... Because I know in my pre-cal book, they had you, like... They had you, what is it? They had you do, oops. They had you do some kind of thing where you have to, like... Well, I know they had you do the conjugate to simplify this expression. But the thing is, what is the other way, you know? I do think the only way I know how to do it is by, taking the conjugate. Otherwise, I don't know how to do it. Like, I don't know any other way to do it. Because, yeah. Give me a second. Yeah, so, this is how I know how to do it. I don't know if you can show me the other way, but this is what I'm gonna do. This is how they actually have you simplify a similar expression to this, except instead of it having cosine, it has sine. So what I'm gonna do is I'm gonna simplify 1 over 1 plus cosine x. Let me do this method first, and then... Yes, I do. I think so, yeah. The half-angle identity is, sine of theta. What is the, which half-angle identity you're talking about? Are you talking about the tan of theta over 2? Is that what you're talking about? The tan of theta over 2? So this is how I know how to do it. Okay, I'll do it that way in a minute and see how to do it, and then I'll end the stream after I'm done with this problem. So, we're gonna multiply... Okay, I see. Hold on. I'll do that in a minute. Now, we know that this part is the sine squared, right? So we have 1 minus cosine x all over sine squared x. You said 1 over 1 plus cosine, right? Or I'm sorry, yeah, 1 over 1 plus cosine. Is that what you said earlier? To do the integral of that, right? I think that's what you said. I have a terrible memory. Yes, you did. Alright. This is, so if I integrate this, it's gonna be, okay, it's gonna go like this. The integral of 1 over sine squared x minus cosine x over sine squared x dx. And so then we're going to end up with the integral of cosecant squared x minus, it's going to be the cotangent x, cosecant x. Or no. No, yeah, I'm right. I think. Hold on. Where's my my calculus book? The integral of cosecant squared x is gonna be, so this part is gonna end up being, so integral of is really the negative cotangent x, and then the integral of cosecant x cotangent x dx is equal to, oh god, is equal to negative cosecant x. But because we are doing like subtracting twice or whatever, like the subtraction of a negative, it's gonna end up being that the integral of cosecant squared x minus cotangent x cosecant x, all of this dx will end up being negative cotangent x plus cosecant x, I think. Oh my god. Plus the constant of integration c. I think that's how you do it. I think. Am I good? Am I right? Am I good on that one? I think. I hope. I can never be too sure. Now, the other way that you were talking about, I'm gonna try to see if I can do it the other way. I really don't know. I can't make any promises, but let's see. when I do 1 over 1 plus cosine x. The integral. Let's see here. Yeah, that's I think that's where you're getting that tan of theta over 2 from. Oh, I see what you're doing. Oh, okay. I know what you're doing. I see what you're doing. That is interesting. I see what you're doing. I see what you're thinking, or what you're saying. Give me 1 second. I am gonna try my best to see in here if, where are the trig identities in here? Oh my goodness. Hold on. Wow, they don't even have the half angles on the very back of the book in here. Great. Oh my god, what are they? I always forget the half angle. I always forget the half angle. I know it is. I know it is. It's supposed to be, because if it wasn't, then we wouldn't be able to do that method. The answers have to be the exact same thing, just written differently. Give me a second, okay? I'm gonna look in here really quick. I have to find the half angle formula. So I think what you're saying is the following, and I do think, I don't know if this is the right one that you're using though. Let me just kind of get in here and try to you know, try to see if I can figure out what you're saying. What you're saying is that the so you're saying you're using this, I think. You're using this. Okay. If you hear a dog barking, I do apologize. Hold on. So, okay, so when we got this, right? I mean, we ended up getting, oh gosh. I'm trying to think here. But the strange thing is, though, I mean, how would you know when, unless you have to do partial fractions, I mean, how would you know if, like, because it would be like saying, It would be like saying the following though. If I rewrite this the following way, let me do this. Hold on. I'm gonna say the following. I'm gonna say that 1 minus cosine x over sine squared x the cosine x over 2 identity. Where is that? Oh gosh. Oh dear lord. Hold on. What was that again? I'm sorry if my dog is barking. Golly. What? Okay, wait. Oh my god. Give me a second, okay? I'm looking. I just hate... Maybe I should just get my calculus book because... Oh god. For some reason, they don't have the stupid identities on the very beginning. I mean, they do, but... They don't have the half-angle ones. Wow, this one doesn't even have them either. Can you give me the one for cosine? I always forget what it is. Hold on, let me look it up. Hold on. I'm gonna look it up. Oh my gosh. And you said to use which one? The half angle for cosine? Okay. Oh, I'm sorry. Equals, plus or it's gonna be plus or minus the square root of 1 plus cosine u over 2. So... I know, hold on. Yes, I know. Hold on. So yeah, we're going to multiply by 2 on both sides. This is going to equal to 1 plus cosine of u. And then minus 1 on both sides. We end up getting 2 cosine squared of u over 2 minus 1 is equal to cosine u. Wait, was that what I was trying to do? I'm sorry, hold on. But wait. I'm sorry, no, not minus 1, right? Okay, yeah, that's what I thought. I didn't have to do that. Okay. Okay, yeah, so just... yeah? Is that right? And so then... is that good? Is that good? Then we're gonna do the following. Oh my gosh. So then what now, though? Hold on. Wouldn't that give you secant squared, though? Like, this is gonna be 1/2 integral of 1 over cosine squared of x over 2 dx, which is equal to the 1/2 integral of secant squared of x over 2 dx. Oh my god, why is it doing this right now? Please. And then finally, we're just gonna, I believe it's u substitution. So it's gonna be u is equal to x over 2. Du is dx over 2. So 1/2 times the integral of secant squared of u times du over 2 oh my gosh, please, which is 1/2 times 1/2 times the integral of secant squared of u du, which is really 1/4. It was what again? I'm sorry. Oh god. I'm sorry. The integral of secant squared is secant x tan x, right? I don't remember. Oh god. Or is it tan x? I know it's not 1/2, it's 1/4. always forget the integral of secant squared. Isn't it tangent? Integral of secant squared is tangent, right? So it's gonna be, it's not 1/4. What do you mean? Oh, I'm sorry. I made a mistake. If I multiply times 2, yes, you're right. Dx is equal to 2 du. Yes, I'm sorry. Oh, we're doing another problem. I'm almost done streaming. I have a few more minutes, so I'm just gonna finish this up and then I have other things to do. But let me, hold on. Sorry. This is, which is gonna be, this will cancel out. We're gonna do the integral of secant squared u du. Which is, tangent, right? Is that tangent? It's tangent of u. Now, what's very strange with this one, though... Well, okay, I got tangent of u for that. But... let's say, negative cotangent plus cosecant x. So we're gonna just go back to the other solution where we had, cosecant of x minus cotangent of x, and we're gonna verify that this is equal to tangent of x, I think. Is that what I'm, is that what I think it is now? Is that not what we had at the very beginning? Like, I mean, is that not what we had with the other answer when we did cosecant minus cotangent? Because that's what I got whenever I did the 1/1 plus cosine. When I did it by, conjugates. So, we're just gonna prove this. Oh, I'm sorry. Oh, I'm sorry. Okay, yeah. And then substitute u back in. So it's gonna be, 1 over, oh golly. 1/1 plus cosine, right? I always forget. It was 1/1 plus cosine. Right? Is that... yes. Goodness. I always forget if it was cosine or sine. Now, we're gonna just prove that, this is the same thing as, tangent of x over 2. And this is gonna I'm just doing this because I'm trying to just show y'all that it is the same thing. This is gonna be it once I finish. Wait a minute. Wait. Are you sure it wasn't... I'm sorry. It's... Wait, I thought it was cosecant x minus cotangent x equals tan x over 2. Tan of x over 2. I thought, but why did you say negative cosecant plus cotangent? It's cosecant minus cotangent, not negative cosecant plus cotangent. Like, I wrote cosecant minus cotangent. Did I make a mistake? No. No, because it turned positive. Cosecant turned positive. What? Somebody tell me I'm correct. I think it was really what I wrote over here when I said cosecant x minus cotangent x. Because I know, but what you're saying is negative cosecant x plus cotangent is equal to tan x over 2, but it's really cosecant minus cotangent, not negative cosecant plus cotangent. I don't know, but okay, as long as it's the same thing. Now we're gonna go ahead and prove this. Did I make a mistake? Like, really, I need to know if I made a mistake. I don't think I did. Let me see. I don't think I did I? Okay. We're almost done. We're just gonna go ahead and prove this so that you guys can, I can show y'all that it's the same thing as our, like, antiderivative when we do the antiderivative. How am I gonna do this one? Gotta scroll up to my answer. What part? Right. Cosecant minus cotangent equals tangent of x over 2. Because that's what we got at the end when we did, you know, the integral of 1 over 1 plus cosine. Okay. Let me see if I can just prove this. I really don't know, but I'll see. What? I mean, yeah, but... Wait, what are you talking about? Where is it? Integral of cosecant squared x. That was this part. That's negative cotangent. But the thing is that when I did the integral of cosecant squared x minus cotangent x cosecant x, it's gonna be the double negative, so it's gonna be plus. That's what I put, and that's why it was plus cosecant. Because it was minus integral of, it was negative this integral, which was really the positive integral of cosecant x. I'm sorry, positive cosecant x. Uh-huh. Yeah, that's the same thing. That's the same thing. That's the exact same thing. Negative a plus b equals b minus a. That's the same thing. I just wrote it that way because I don't like to do the negative first on the bottom. Like, yes. Yes, it is. Cosecant x minus cotangent x is negative cotangent. So, like, a minus b is negative b plus a. Excuse me. Yeah, it's just algebra errors. It's okay. Oh my god. Okay. I'm gonna try to turn everything. Actually, I don't even know if I can do the. No. That's why you have to be careful with the signs. Where in the hell did I put sine of u over 1 plus cosine u? Oh my gosh. Please. We're almost done, guys. I'm just proving this, and then that'll be it. Oh gosh. Why does it keep doing that? Jesus Christ. Come on. Okay. I always forget my half angle. Oh my gosh. Oh my god. Oh my gosh. Let me think. I'm always forgetting my half angle identities. They're annoying. Hold on. They're very annoying to remember. Goodness. Where are they? Excuse me. This is gonna equal. So this will equal the following. The square root of 1 minus cosine of x over 2 over The square root of 1 plus cosine of x all over 2. No, Ryan, I am not doing disk or washer method. That is very complicated. I'm sorry. I cannot do that. I don't know how to do that. I have to see it. Like, I have to see an example to compare it so that I can be able to do those kind of problems because, yeah, if I don't look at a textbook or at, like, you know, the formulas, then I'm screwed. Disk and washer method is I understand it once, you know, once they give me an example or they tell me to use that method, but yeah, no, I don't do that stuff on my YouTube channel because it's really difficult to explain since I really struggled with that in Cal 2. Yeah, I hated that entire chapter. It was really effing annoying. I hated it. It was frustrating. I hated that chapter so much. And I never want to do it again. But where was I? Come on. Why does he keep doing this? Oh my gosh. Oh my gosh. Give me a second, everybody. Give me a second. Give me 1 second, guys. I'll be right back. Hold on, hold on. Oh, gosh. Okay. Hopefully it's fixed. Golly. Erase this, please. Oh my gosh. Okay. I'm sorry, guys. The last math class I took, to be honest, was Cal 3. And I do not do Cal 3. It is too difficult. I can do some things in Cal 3, but, no. Like, I hated that class, and unfortunately, I took that class while, during when my mom, was, she had cancer, and so she passed away around that time, and oh man, it was one class that I just don't want to remember because it just gives me terrible memories. But, yes, I took Cal 3, I almost dropped it. I really, really, really tried, but I was in such agony from grief, like grieving for my mom at the time, that I could not focus. So So that's why, you know, yes, I still passed it. I got a C in Cal 3, but I never, I never want to take it again, and I don't go over it because I don't even tutor it. No. No, 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 no. Thank you, prods. Thank you. I really appreciate it. So, this is 1 minus cosine of x over 2 times 2 over 1 plus cosine of x. And so, I mean, let me think here. Hold on. We wanted to prove what again? I'm sorry. Oh, okay. I wrote what? I wrote what again? I'm sorry. Say that again. What did I write? As cosine of x? What did I write as cosine of x? Okay. So then these cancel out. We're going to end up with the square root of 1 minus cosine x over 1 plus cosine x. WSX is cosine x. I don't see where I put that in. Where did I say that? Oh, I'm sorry. This is supposed to be cosine. It looked like a W. Thank you. That was cosine. Cosine x. 1 plus cosine x. It's not W, it's cosine. Yeah. It just looks weird. I rewrote it. My bad. Okay. Now, there is still the question of how does this equal tangent of x over 2? Well, what I'm going to do is I am going to do the following. Because our goal, again, guys, our goal is to get it so that it equals 1 minus cosine x all over sine x. So, yes, we are working with both sides. I mean, yes, you can always, like... you know what? I'm just gonna keep it as cosecant minus cotangent. Okay. That's cosine, guys. Just don't... That's how I write my cosine. I'll write it a little better here. There we go. So our goal is to convert this to that. So now, what I'm gonna do, guys, is I'm gonna rewrite the right side as the square root of 1 minus cosine x, and I'm doing it again. Over the square root of 1 plus cosine. I always write it that way, guys. It's a habit, okay? It's cosine. I need to break that habit because I just don't want to confuse anybody. Okay. What we're going to do, we're going to go ahead and multiply by the conjugate. Now, here's where I do want to ask everybody a question. Is it better to multiply by the square root of 1 plus cosine x or by the square root of 1 minus cosine x? I think we always do the reciprocal. We always get rid of, so we always do the, like, if I have the square root of a over the square root of b, this a can be a 1 minus cosine x, b can be 1 plus cosine x, and we're always going to do the reciprocal of, I'm sorry, the conjugate, or rationalize the bottom. So it's going to be the, I mean, yes, the conjugate, but I don't want to say that because it's literally just going to be the square root of 1 minus the square root of 1 plus cosine. I'll explain in a minute. The reason is because we're just really going to do this. B is 1 plus cosine x. Trust me, just trust me. Just trust me on this. Just trust me on this. It's just better to do it this way. Wait. You know what? Actually, you're right, prods. We're gonna go ahead and do the times 1 minus cosine, yes. Because I'll explain it, guys. Yes, you can do the 1 plus cosine, but just trust me. You can also, the best thing to get it to the way we're trying to do it is to do it this way. Times the square root of 1 minus cosine. I know it looks like a W, guys. Just ignore that. It's a cosine, okay? It's cosine. Oh, God. We're almost done here. This is going to be 1 minus cosine x over square root of 1 minus cosine squared x. And if y'all remember earlier, from the Pythagorean identities, the 1 minus cosine squared x will go on the bottom. This is supposed to be cosine, guys. Just I write it that way by its habit, okay? We're almost done. This is going to equal 1 minus cosine. What? Okay, I mean, I'm not tutoring, but I'm doing a live stream, so... Wait, what?
I said if we want to get chicken later, like I said.
Am I gonna have to go?
Yeah.
Oh my God. Well, I'm almost done. Just give me a minute. Godly. I'm sorry, guys. I should have muted myself. Oh, God. I should have muted myself, guys. I'm sorry. We're getting chicken later. Okay. Anyways, let's finish this. Where was I? This is gonna give me 1 minus cosine x over... And remember that the, what is it? The Pythagorean identity. This is gonna be sine squared x, but it's gonna be the square root of that, which is really equal to 1 minus cosine x over sine x. And so by the, and so our, original, expression, guys, was the fact that, this entire thing is really cosecant x minus cotangent x, and that is why the tangent of x over 2 is what that is. So cosecant of x minus cotangent of x is equal to, and it's going to be 1 minus cosine x over sine x. And this is the exact same thing as tangent of x over 2 because of this entire thing here. And that is why in our integral, that is why in our antiderivative for the final answer, we ended up with tangent of x over 2 plus c, because that was the exact same thing as when we did the reciprocal of, I'm sorry, the conjugate of 1 minus, or 1 plus cosine x. If you put all the pieces together, guys, you just have to see it. Look at everything I did and just try to put all the pieces together. I'm not really going to try to explain everything again because, yeah, and thank you, I don't know if it was Light or Prods that told me about that method. I don't even remember. Who was it that told me about that method? The method without doing the conjugate. Was it Prods or Light? Okay. Well, guys, originally I was only gonna do one problem, but oh, okay, thank you, Prods. So yeah, I thank you for giving me that method. It was very interesting. That is going to be it for this live stream, guys. Thank you so much for watching. I hope I can see y'all next time when I live stream. If you're not subscribed, please subscribe. And also turn on the notification bells to know when I upload a video. But I wanted to do the integral of secant on this live stream because, yeah, that one was a really tedious one to go through, and it involved a lot of just math. So if anybody has any questions, oh good, Prods, if you could subscribe too, that I would really appreciate it. Thank you, Prods. You can also watch some of my other videos. I did upload one today, I think. Or was it yesterday? I don't remember. Oh yeah, I don't do, unfortunately, I don't do, hyperbolic, They never taught me that in calculus. I don't know why they didn't teach me that. They never taught me that stuff. The hyperbolic derivatives or integrals. It's just crazy. I don't know why they didn't teach me that, but with that being said, guys, thank you so much for watching. Hopefully I can go live again soon. I just been so busy, but I really appreciate everybody who did watch, even though it wasn't that many people. I really appreciate y'all. I am gonna go take a shower really quick. Hopefully I can. And then I will go ahead and just upload more videos later. But that is going to be it for this live stream, guys. Thank you so much. And I will see y'all next time. Bye, guys.